function, example 4, graph, and find the domain and range of logarithmic function f of x is equal to the ln x plus 2. First of all, if we are doing a transformation of logarithmic function, it's good to find out what is the parent function of the family ln x plus 2. So the parent function of ln x plus 2, it is a function f of x, or let's say y, okay? Because I just want to write a bit different denotation. Let's say y is equal to ln x. So let me write a much simple. And if I wanted to write y is equal to the ln x, so easy way is here. This is a 1, okay? And this function, what it's going to be, is going to intercept 1. And approximately, this function is going to look something similar like this. Okay, let me erase everything. Let me erase everything, sorry. This function is going to look something this way, okay? So this function is going approximately to look in this form. And what's happening here in this function, it has a vertical asymptote, which is x is equal to 0. And the domain of the function y is equal to ln x is from 0 to infinity. And the range is from minus infinity to infinity. Now let's rely on this function ln x, and let's find the transformation function of ln x of y here in f of x, which is ln x plus 2. And we already know this ln x plus 2 is going the parent function to move 2 units into the left. So if we are moving 2 units, 1 unit to here, 1 here. So the y-intercept is going to be here. X-intercept is going to be minus 1. But even if we are want to prove it differently, for example, if I want to find the x-intercept, so I'm making f of x is 0, and we find the ln in x plus 2. ln x plus 2, okay? So this is one easy way. And what I'm doing here, I'm going to lnize everything. And if I'm lnizing everything, then what's happening is going to be inner 0 is going to be equal with the e in ln x plus 2. ln x plus 2. So what's happening here, ln x plus 2. What's going to happen here? E in 0 is 1. And e in ln is going to be x plus 2 times e in ln, which is just x plus 2. And now both sides I'm subtracting minus 2. In this side and this side here. And what's going to happen? What is going to be the x? The x-intercept is going to be equal with minus 1. What already we have adjusted from the transformation of the parent function that is going 2 units. This intercept is going 2 units, is going here. So we just prove x-intercept as x equal minus 1. But my point here is to find the y-intercept, because if I am transforming this function, parent function is going to, even if it's going to unit here, it's going to intercept y somewhere. I don't know exactly where, but let me find the exact value of the y-interception. If I want to find the y-interception, what I'm going to do here, I'm going to make x 0, and I want to find the y. So let's say x is 0. Let me write whenever is x, I'm going to plug in a 0, because I want to find the y-intercept. So ln is 0 plus 2, which is ln 2. Okay. So, and f of 0 is equal to the ln 2. So f is going to be equal with the ln 2. Okay. So this is what's going to be. If I want, for example, to find the more correctly ln 2, I can find here in a calculator. So which I can write 2, for example, and I'm going ln, which is 0.69. So the value is going to be 0.69. That is going to be here somewhere. Here is going to be somewhere this point of an intersection. And then what happened then here, because as I said it before, y ln x is going to have the vertical asymptote x is equal to 0. So this asymptote is going to move for 2 units into the left. So it means, what does it mean here? Let me make here with a different color. So x to equal minus 2 is going to be the vertical asymptote for the function f of x. So this is the asymptote here. Okay. So x is equal to the minus 2. So let me write in this minus 2. And now, approximately, I can connect those 2 points here. Okay. So this is the function of the f of x. And f of x is going to be something similar. It's not a very on a scale. That's why it doesn't look very beautiful, those everything in the scale, but this is approximately how it's going to look. And this is a f of x. This is a f, and the function here, this is a y function. Okay. And now we see it has the vertical asymptote of the function. X is equal to minus 2. And here, because we are looking for the domain and the range of this logarithmic function, let me state what is the domain. Domain we already see is here. The domain is from minus 2, but because this is an asymptote, it does not include, but is an open interval. The domain is open interval from minus 2 to infinity. This is the domain. And what is the range? And the range of this function is going to be, so the range as we see is from minus infinity to positive infinity. So it's all real numbers, or from minus infinity to infinity. So this is the range of this logarithmic function f of x.